Hey everybody, happy weekend. Mr. Fortin here. I got a great email that came through just about an hour ago here, and it's this: how to do the proof number 5 challenge in the Desmos. Oh gosh, man, that was quite the doozy to take care of over the weekend here. Or maybe you did it on Friday. I don't know. I remember in class here, some people busted through numbers 1 through 4. They were a bit easier. And then number 5, challenge problem for sure. So maybe you figured it out towards the end of class, maybe you took it home, and maybe you're just still stuck banging your head against the wall, being like, how does this one work? So I want to commend this person for asking me this question. I'm going to go through it right now. Here, I already have it done down here. I'm not going to show you the answers. I want to go through it step by step so you kind of get it here. But I also want to remind you of what I told you in class, near the end of class here. The thing with geometry problems, right? The thing with geometry problems is that oftentimes the questions, it's really easy to come up with questions that are either too easy or too hard. Okay. So for the ones that are too hard, right? I know everybody here wants to kind of get it all. This person, right? Got to give him credit here for working hard. I know this person works hard in class. And they also send me emails, right? Send me an email here. They ask for help, which is a very, very big with me. I got to see you trying hard, and I got to see you asking for help. And then it's going to come together for you, and I can help you out here. Okay. Also, want to give credit for this person here too. What a professional email. This is a very professional email. So, very good here. And this is how you ask for help. Use this as an example in the future. Dear Mr. Fortin, I've tried many times to solve the last problem in the Desmos activity, but it seems like I'm having difficulty properly organizing it into its right order. Is it possible you can help me on it? If so, thank you so much. Sincerely, redacted. So let's go ahead and do this right now. I think it's a great question. Sure, I can help. I can try to help right here. I'm going to go through my whole mindset with this and the things that I'm thinking about. And really, like, that's another reason, a big reason why you go to school is to figure out how other people think, right? How other people think, so that you're not just in your own world, just constantly analyzing, how do I think? How do I think? No, you want to get into other people's heads here. So hopefully I can get in my head here and figure out how this thing works. Because this was, not even straightforward for me here. Okay. Also, too, you might not have noticed this on the left side of the Desmos here. There are a couple hints. Okay, there are a couple hints. I'm gonna maybe open it up here. Symmetric properties used before the segment addition postulates there. Okay, so one of our first 4 steps is the symmetric property. And then subtraction property would be one of your 2 last steps. Okay, so we can keep that in mind here. I'm going to figure it out because I actually didn't know there were hints there. I'm going to talk about how you can get it from start to finish without relying upon those hints here. Okay, first things first, easy thing. What are we doing to start this proof? Okay, a lot of times you want to go in, you just like, I just want to start the proof and just write it in order and get it all done. You're going to see here why that's going to be a little bit hard in a second here. But the easy thing for you to do to just get started with this is, of course, what's the first step? Well, we're freaking given this. If AE equals BD, AE equals BD, so those holes, and then these parts here, CD equals CE right here, the parts of the whole segment, part of the whole segment. If they equal each other, then it has to follow that AC, this segment, and BC have to equal each other. And this proof is more complicated than it needs to be. I think one person in class here, maybe it was Fiona's 7th blog, was like, why is it so complicated, this proof? Because this proof's not that hard to write on your own. So sometimes that happens with fill in the blank proofs. And then, right, somebody proves it this way and they want you to like figure out how they proved it. And it's really hard that way. So this gonna gets again into what were they thinking? What were they thinking they wrote this 7-step proof? Okay. Anyways, first step here, I think, hope you all know it by now. Well, if AE equals BD, and CD equals CE. Yeah, it's your given, okay? You can just assert your given premise as the first one. The given premise, like 90% of the time, is going to be your first step. Okay, you get it there? You get it now? The first step is going to be given premise. All right, let me find the given premise. Given premise is down here. It looks like AE equals BD and CD equals CE. And we're looking for my given, and that's right here. Gonna grab it, move it over here. And maybe I'll grab the screen, move it over this way so I can more easily grab the reasons here. Okay, next up, what do we have? AE equals BD, CD equals CE. I've used that in the given here. And then they built on it. So this is what they did here. They did AE equals AC plus CE. Well, what did they do? I see AE here. I see BD there. Wait, AC plus CE replace BD? Wait, how did they do that? Wait, we adding something here? Oh, wait. We're only adding something to one side of an equation? What? Only adding one thing, one side? Okay. Wait, you should see this now. Part plus part equals whole, right? Part plus part. Check it out here. AE, where must they have gotten this? AE is the whole segment, and we have AC, that's this part here, and CE, that's that part there. So here, this is that part plus part must equal the whole length here. And we know we have two postulates for that, one for segments and one for angles. Part plus part equals whole. Part plus part equals whole. Okay, so it's either the angle addition postulate or the segment addition postulate. What are we dealing with here? We're dealing with segments. Okay, so I'm going to pick the segment addition postulate, the rule that in order to create a relationship between, if you have three collinear points right here, right? Way to create a relationship between this length and that length and the whole length is, well, it's the part of length, and then this partial length here equals the whole length here. Part plus part equals whole. Okay, feeling pretty good about that one. Then you're going to go in, and maybe you're trying to get step 3, and here's where it gets a little dicey. It's like, well, what are we going to say next here? Like AE, let's see if we can find AE. You know, they don't say anything about AE in any other statement. Any other statement in this proof. There's nothing said about AE, right? Let's see AE. Yeah, they're done with AE, it looks like. Huh, interesting. Okay. So AE was up here, and AE doesn't appear anymore. AE doesn't appear anymore. So what happened? What happened to AE? I'm thinking about it differently now, going through it right now. What happened to AE? Well, AE probably got replaced with BD, right? Like, check it out here. None of my other statements here have AE in it. So where did AE go? It got substituted for. Ah, yes, it did. Okay. So anyways, we can maybe look for a BD being on the left side here. So maybe this one, because BD could get substituted in for AE right here. So BD, does that equal AC plus CD? Well, I see AC and I see CE right there. Wait a second. CE also equals CD. CE equals CD. And wait, I have CE here, and I have CD right there. So yeah, if you're following my logic here, it's going to be this one. But if you got stuck on this one here, I might recommend you do this. Think about filling in step 5, because guys, actually 2 easy steps we can fill in right now are step 5, because we know that's the other segment addition postulate. And then what other step? What other steps like super easy to fill in right now? Well, we filled in step 1 with the given premise. Is there another step where this guy's going to appear? Yeah. Okay. The last step of a proof is ultimately that freaking statement that you're trying to prove. You're trying to get into the proof here. If AE equals BD and CD equals CE, then it's going to follow that AC has to equal BC, right? Then it's going to follow. So all this work to get the AC equals BC to follow is necessary to justify why it's true. So we're doing all this work to or finally get to AC equals BC in the very last step. So that must have been their very last step. And their proof is too long, right? The 7-step proof, I mean, I could show it maybe a different way if you guys are curious here, how you can prove something that's faster than 7 steps. So they're doing too much work and making your lives too much here, right? By filling this 7-step challenge proof here. Okay, so that's going to go there. We don't know the reason yet. Let me just point out that way. We don't know the reason yet because we don't know what's going to come in step 6, but now I'm just filling in things right now. I'm trying to, like, it's like when you're doing a fill in the blank and there's a word bank. I'm trying to move stuff into the table here, and I'm crossing stuff off, so that gives me fewer options to fill in these things over here, because right now I have 1, 2, 3, 4 remaining statements. Okay, so I think I can figure this one out. Okay, that one's here. Let me fill in the segment addition postulate, because this is how I did it originally, right? I was like, well, I'm going to fill in the easy stuff, what I know here. We already did segment addition postulate up here. We did AE, that's the whole segment, equals AC, that's this partial segment of the whole segment, plus CE. Add them together equals this thing here. But have we done it for this one yet? Have we done it for segment BD? Well, segment BD equals what? Segment BD, if I flex the segment addition postulate, segment BD equals BC plus CD. So that's the one that I'm looking for here. BD equals, not AC plus CD, BD equals BC. So BD equals BC plus plus CD, which is right here. Okay, so I'm filling that one in. So that's that. These are the first 4 steps that I put down, because these are all very obvious. Okay, start with your given premise. Okay, segment addition postulate. Well, that's just segment addition postulate written out here, right? Part plus part equals whole. So you notice that and you filled that in. This other segment addition postulate, that must be with the other whole segment and its 2 parts here. And then the proof statement, the conclusion is always the last step of the proof. Okay, this thing prove here, your work's not done until you said it. So then your work's done as soon as you say it here. So AC equals BC is the last step. Okay, so that was the easy stuff here. right? I just blabbered on about for 10 minutes is the easy stuff here. The harder stuff is getting everything else to fit in here, okay? So the way that I did it, I think earlier was how would I go from step 5 to step 7? I maybe thought about it that way. And then I'll go back up to step 3 because I think that's kind of the hardest step here. But anyways, BD equals BC plus CD. Check it out here. So how do we do that here? Well, AC is right here. We're not really talking about that right now. BC is right there. Oh, interesting. I think I grabbed this. Okay, I noticed that I had this one right here. Check it out. This one here connects, these two are going to connect together because what do we notice? We have BC plus CD and BC plus CD on the same side of equals. Okay, BD, what does BD equal? Well, BD equals AC plus CD. So anyways, this was a little confusing. Maybe I actually didn't do this one next. I didn't do this one next. Let me get back to what I originally did next here because I actually figured it out. I figured out how step 2 could connect to step 3, and I've already kind of explained this video. So the one that I'm going to put in here is this, okay? In place of AE, because AE, look, AE is not in any of the more steps, right? AE is done after step 2. There's no AE here, there's no AE here, there's no AE in any of my remaining 3 options or 4 options that are going to fill right here. 3 options that are filling right here. So that means that AE got replaced by BD. So that should give it away. This is going to be step 3. Okay. This is the hard thing to kind of notice here. Maybe I'll switch to this screen so you can actually show it to you without showing the rest of the proof here. This is the substitution property of equality because let's just like look for a second what happened. Well, AE is just in our first 2 steps. I didn't have any other statement that had AE in it here. So that means that BD, oh, I got a big old thing here. I may need to make my pen a little smaller. Hold on a second. Thank you guys for your curiosity in watching this whole video in case you like really want to get it here. And I'm gonna take BD and I'm gonna replace AE right here. That's what happened. Okay, that's why BD is right here. Okay, substitution property of equality. BD goes in for AE. And wait a second, AC plus CE, that's not in my next statement here, okay? So I know if AE equals AC plus CE is true, and I know this, then I'm going to replace AE with BD. Wait, CE changes to CD. Why? Well, same reason. Same reason. Check it out. CD is right here. CD is right here. And I can replace CE with it because it equals CE. Okay, BD, I can replace AE with it, and then we end up with that with it down here. BD, I can replace AE, we end up that down here because it equals AE. Okay, it equals AE. CD equals CE. We can replace CE, and then that's why CD is going to play there down there because I replaced it with CD. Okay, so that one's substitution property of equality. Hopefully you see it, right? Hopefully you see it. It'd be hard to see substitution property of equality, and it can be hard to see transitive, I think, too. I think those are some of the harder ones to kind of get here. Okay, so I'm going to go ahead and drag substitution property of equality in, and let's go ahead and bring that right here. Next up, okay, so I have BD. Well, BD is over here. Oh, AC plus CD. Let's check it out here. Ooh, it's on the other side of equals. What's that one where if this equals that, then the reverse is true, right? Then that equals this. What's that one called again? That's a symmetric property of equality. So that's what's going on in this one. So you can pretty easily tell that this one certainly, oh wait, no, sorry, this one, wait, where did it go? Yeah, this one. This one certainly connects to step 4 because all 3 of the things said in step 4 connects, this one connects to step 3 because all 3 of the things said in step 3, BD, AC, and CD, are repeated here in step 4. It's just, we're just changing up the sides, right? Changing up the sides here because ultimately we want to say AC equals BC. We don't want to say BC equals AC. So anyways, we got to use symmetric property at some point, I guess. And let's move it on in here. Okay. All right. I think you hopefully see that. Okay. Symmetric segment addition postulate. Already talked about that one. That one's in here. We're like freaking done with this, aren't we? This is gonna be the last statement. And we're gonna maybe talk about why it's true here. Well, BD, oh, in step 4, check it out. BD equaled AC plus CD. So that's why instead of BD in the left side of the equation here, we see AC plus CD, right? Because BD equals AC plus CD. Here, the right side of the equation is preserved, right? From step 5 to step 6, we have BC plus CD. So that's simply transitivity. Okay, simply transitivity here. You might be thinking for a second, if you're also new to this here, why is it transitivity and why isn't it substitution? Well, remember the difference between transitivity and substitution is that transitivity is when you specifically have three things, three expressions. Okay, three expressions here, and we'll look at those three things here. That I got BD, three things that are connected through one thing, right? Here, BD, what does it equal? It equals AC plus CD. BD also equals BC plus CD. So two things, right? Here, number one and number two things that each equal the same thing are equal to each other. That is the conclusion we're making in step 6. And that's transitive property of equality. How it gets kind of said in common language is two things that are each equal to the same thing are equal to each other. Okay. Got transitive there. And for that reason, right, BD was in both of these, but they were equal to different things in both of these. But if they're equal to the same, to different things, those different things got to equal the same thing because, BD is just one number. It only equals one quantity, right? Like equivalent amounts. Okay. Last step must be this subtraction property. Yes, check it out. I got my great job. Hopefully you get the great job too. Subtraction property of equality, because I have CD on both sides of the equation. So I could say reflexive property if I want to, say CD equals CD, and then that gives me permission to subtract the same thing from both sides of an equation here. Okay, so this is kind of one of the hard things also too about geometry is that you don't see, you don't like it changes, but the change isn't totally explained to you here. So here, what happened between step 6 and 7? Well, these are just the same freaking equations. What went missing? CD. Why is it allowed to go missing? I'm allowed to subtract equal numbers. Remember, CD is a number. We don't see any segment symbol or anything like that above it. We just see 2 points, and that's just the length between the 2 points right here. So CD minus CD, cancel them out. CD minus CD, as long as I subtract equal quantities from the same side of equals, my equation will remain balanced, right? I'll mean the same amount, and I will arrive with what it was I was trying to prove at the end of the day. QED. Stick a fork in it. You're done. Thank you for this question here. Wow, impressive that you watched the whole video. If you did, take care, guys. Bye. Let me know if you have any more questions too. Send me a great email like that. Bye.